It is additive in nature. You
Okay.
can add the
Addi-
charges.
yeah, additive in nature. Okay. Anything else?
And the value of charge, okay, I told it.
Anything else you want to add?
No, sir.
Okay. One thing you missed.
Charge is independent of motion of particle.
That is, yeah, invariant. That is, it's invariant. One thing is missing. That is charge body. Charge body.
Attract a lightly uncharged body.
Yeah. Light uncharged body. Like example, balloon and wall.
Okay, sir.
Important, very, very important topic that throughout your 12th standard you will see everywhere this thing. That is Mr. This actually we have studied in 10th standard also, but not as a syllabus part. Okay. So there are Q2 separated by distance R. Okay. So for attraction or repulsion between two charges is the product of two charges, to Q1 and Q2, directly proportional and equal to distance between those two charges. So what we got here, F is proportional to Q1, Q2 by R square. To we have constant F equals to K Q1, Q2 by R square. Now this is F equals to K Q1, Q2 by R square. Now K is 4 epsilon. Epsilon naught is permittivity.
So that's basically like a law of gravitation, right?
Exactly. That is discuss that.
So your voice is breaking.
Yeah. Anyone that is they ask in one board exam also.
So your voice is not clear. It's breaking.
Okay. Am I audible?
Yeah.
Yes, sir.
Is it clear or it's breaking?
Now it's fine.
One Bluetooth got discharged. Only one Bluetooth is working. Fine. So this is what we will relate this one with the 1 by 4 pi epsilon naught. Epsilon naught is permittivity. Have you heard this permittivity? Can you hear me, guys?
Yeah, so can you repeat your question?
Okay. Is it not clearly audible? I'll off this.
You're audible now.
Now am I audible?
Yes.
Okay. Fine. So I was asking, like, have you heard this permittivity?
Yeah.
This permit.
The ability, like a permittivity, measures the ability of a material which can store, like how much energy it can store.
It isn't. It is a property that allows a medium to allow the medium to pass electric charge, like electric field through it.
Yes. Permittivity means it's a property now resistance it resists the flow of current. So here this is permittivity, it resists the flow of electric field. It will just measure how much electric field is. He will just keep field, how much and all that. So this permittivity, we have to see this detailed one part with permittivity, because permittivity is 8.86 into 10 to power minus 12 or 8.85 into 10 to power minus 12 coulomb meter. Now, how we got this unit? How to get this unit? By this formula. Let's 4 pi epsilon naught q1 q2 by r square. Now we want epsilon naught. 4 pi there doesn't have any unit. So epsilon equals to q1 q2 by f r square, because E and F will get exchanged. So here are charges, Newton, R square is meter square. So by this we can form unit. Now there is some relation between permittivity of free space and other media. So which is epsilon is equals to epsilon by epsilon naught. So this is what relative permittivity. And this is permittivity of free space. And this is permittivity of for free space. Now for free space standard value, as I wrote before, it is this one. By 4 pi epsilon naught, his standard value is 9 in 10 to power 9 Newton meter square coulomb inverse square. Now, if you want to just do division 4 pi 8.85 into 10 to power minus 12. If you divide this by 1, you will get this value. Can you guys see my screen?
So your voice is breaking again.
Okay, what about now?
Now it's fine.
Voice break immediately you can.
Sir, still your voice is breaking actually.
अरे अब क्या करूं मैं? सब ब्लूटूथ लगा. फोन किधर है? It's 80% charge. Why not? Okay. I guess now it is clear, right?
Yes, sir.
Yes, sir.
God. Okay. So as I was saying, like this is what a relative permittivity. This is So this standard values will be given in question, and this value epsilon naught value we should remember, that is 8.85 10 to the power minus 12. Now if you divide 1 by 4 by 8.85, we'll get 9 10 to the power. So all that just into 10 to the power 9. Okay, so let's go for next thing. Force. This can be expressed like this also, 1 by 4 pi epsilon naught epsilon r into q1 q2 by r square. Now epsilon relative power is 1. That is why we have formula as this kq by k as 1 by 4 pi epsilon naught. Okay, epsilon r1 for some standard mediums. Now for why I'm taking as 1, because I'll just give you some values for air vacuum is 6 or 6 7 something, I don't exactly remember, but something like that. 1 here. For water also 1.0023 something, 26. L infinite, it's big number. So this is our k value. K means epsilon r. So that is the reason we are taking as standard value as 1. It's called, this k and epsilon naught are called as dielectric. Now dielectric means an insulator. In detail in next chapter, but just now for now we have just introduction of it. Dielectric is just type of insulator. Okay, so have you seen this? Have you seen capacitors?
Yes, they store electric charge, right?
This what they do?
So they increase the capacity of storing energy.
Okay. Look up. We have fan there, and that fan there is one white color capacitors. Have you observed that white color capacitors? Are you?
Yeah.
So what it does, like it will just store energy and discharge. Yes,
It's
but that
kind of
can
an
be.
insulator, right? Like it's kind of an insulator which stores energy, and then like it lets like then we can further use it if we want it any time.
But instead of that, can we use a power bank? Can't we use power bank? Power bank also store energy.
Because like for like machines and all, we need like huge quantity of energy, right? So yeah.
If I tell you like capacitors are very, very, very less, just 2 volt, 3 volt, or 2 ampere, very, very small. Now, okay, then let me rephrase your statement. What you said, that is partially right. Now, capacitor work is to store energy. Yes, right. Of capacitor immediately discharge to give all energy together. If we see power bank, we can take power bank as per the required energy only. We'll just connect our charger to phone or adapter or whatever it is. We'll just take required energy at the time. But capacitor, what it does, immediately it will give it back. So it is now
So
for
your
doing
voice
that.
is breaking.
Now, instant charge and instant discharge, there is a function of capacitor. If I take two plates of capacitor in between, let me draw and show you. Okay, so if I keep two plates like this, so this, every time and we want, whenever it is required, that time only it should work. So what we'll do, we'll keep something in between, that is insulator. And we cannot keep insulator itself. We need something that can be in rare case. Means whenever we want, whenever we give very low voltage, that time we should conduct, otherwise it should not conduct. So that comes here, that is we conduct very negligible conduction, only negligible conduction it is required then, or generally it is what, insulator only. This thing in when it is like how it works, and metal it is so big value. Generally we use mica as in this one, dielectric. We use under is the insulator. Okay, is it audible or it's breaking still?
So it's not that clear.
Yeah, there is a little breaking in between, but
Array. It's about my Bluetooth. So let's see difference between electrostatic force and gravitational force. What is gravitational standard?
so can you repeat the question?
What is gravitational force?
So it is a force between two bodies which is directly proportional to the product of the masses and inversely proportional to the square of distance between them. And it acts
Distance
along the
between them.
line joining the centers.
Okay, so it is strong force or weak force?
It is a strong force, but
Force.
not as much strong as compared to electrostatic force.
What are four fundamental forces?
Gravitational force, weak nuclear force, strong nuclear force, and electromagnetic force.
Okay, so yes, that's right. So nuclear force is the strongest. Okay, then comes that magnetic, electrostatic, then magnetic, then gravitational. So this all are a weak nuclear force, this is strong nuclear force, and this is gravitational force. Force is the weakest force. So here we can say weak force. D and D. Weak force. It is strong force. So gravitational force is attractive or repulsive?
Gravitational force is only attractive, whereas electrostatic force is both repulsive and attractive.
So charge can be attracted and repulsed. Now, it is constant everywhere. Gravitational force is constant, depend upon the medium. Does not depend on medium. So it depends upon what type of material, what. So it depends on charge. So all this basic thing. Now we saw one equals to epsilon naught r square. So let's write this in vector form. So for f, same condition I'm taking f1 to 2, 1 2 equals to 1 by 4 pi epsilon naught q1 cube r12 vector, or we can write r square r cap. This is your vector. Now so we'll see that in code. This is okay, fine, nothing much here. But one thing we need to understand, that is superposition. Charges between multiple charges. If there is a point charge here, Q1, and there is one charge kept here, Q2, somewhere here, Q3, somewhere here, okay, this is Q3, and so on. Okay, so distance between 1 and 2 is R12, distance between 1 and 3 is R13, distance between 1 and 4 means R14. This all are vector position. So sum all will give you total force on Q1. Total force on Q1, that is 1 by 4 pi epsilon naught sum Q1 is constant and Qi for 1, 2, 3, 4, 5, whatever number it is, by R1I square, then to 1 bus, and vector form R1I cap. This is null vector. So what I did here, I just added all charges with respect to Q1, sum of all charges with respect to Q1, and position vector with all those Q1, Q1, Q1 and Q2, R13, R14. Simple. Nothing big here. Are you able to understand what I'm saying here?
Sir, could you repeat that F1 point once again?
Yeah. F1 for force on Q1, because all the charges are related to 1 here right now. For this case, what I would is all to 1.
Okay.
That's why we wrote as distance R1, distance R12, R13, R14. So R12 means distance between positional Q1, and R13 means this Q1, Q3,
Okay, sir.
R14, like that, and so on.
Okay, sir. Now I get it.
Okay. Next, we will see distribution of charges. Let's say like this. Continuous distribution of charges. Volume. Now, volume charge distribution, if I say here simple, like there is some object, or a cube. Let's take one cube. In that, Q charge or some charge is distributed uniformly throughout the volume. That is called volume charge distribution. Nothing, good thing. No. So if I take this cuboid, a cube, if I talk about this much portion, this volume of it. So what it says here, volume charge distribution rho is charge per unit volume. So unit will be cube. Are you able to understand what I'm saying? Charge per unit volume. Surface charge distribution. So if circle, if I'll take portion of this one, so charge per unit area for one area. So for that per meter square. Now last one, linear charge distribution. Now can you guess this one? What is it?
Q by L.
Yes, Q by L. Charge per unit length. Lambda equals to charge per unit length. So if I take some portion of pipe like this, so this is what? DL. This is DA. This will be your DV. So for small, we will take here dq by, sorry, rho equals to dq by dv. In this one, second one will take sigma equals to by d. In take dq by dl. Simple. So let's correct all the formulas for sigma, sorry, rho dq by dq by dA for what is it? Lambda dq by dl. These three. Yes.
So your voice is breaking actually again.
Okay. Again. So did you hear what I said? Like distribute volume, area, and length. Charge per unit length, charge per unit area, charge per unit volume. All is three.
Okay, sir.
Okay, then let's do some numerical with this. Let's start with some easy. Piece of polythene is rubbed with wool. So charge of 2 into 10 to the power minus 7 coulomb is developed. What amount of mass is transferred? What amount of mass is transferred to? Tell me. What amount of mass will be transferred to polythene? And yeah, by the way, mass will transfer or not?
So it will.
So if electrons are transferring, the mass are also transferred.
Exactly. This, if you observe also, might be different or similar type. Let's have chosen some easy question first.
So
So
should we
once you finish one,
multiply the mass of electrons with the charge to find the mass transfer?
yeah, 9.1 10 to the power minus 31.
And by 2 by 10 power inverse 7 we have to do.
Not divide by things, so it should be, let's solve. So Q equals to NE, so N equals to Q by E. So Q is 2 into 10 to the power minus, keep it like that. So mass transferred equals to mass of electron into number. So 9.1 into 10 to the power minus 31 into 2 into 10 to the power minus 7, 6 into 20. So if you solve this, we'll get answer to 9.1 divided by 8 or 91 divided by 8. 8 11s are 2. Something 3. Let's take 3 into 10 to the power.
11.38.
Okay, 38. Okay, fine, 38. So this is 38 minus 19 means 9 minus 19 kilogram. Plus 19 is minus 19. Easy?
Yes, sir.
Yes, sir.
So test 2. Okay, let's see.
So can we do a question on induction, like the charge induced, something like that?
It's like the let's take this something like comb is rub on a. Okay. Actually, I was about to give this question for your test. Yes, I'm not solving that. Okay, I can only solve. So here it says a comb runs through once. Now it attracts small bits of paper. Why?
Because it induces charge.
So options are here, like let me give option then. Comb is good conductor. Paper. Fourth one, atoms in paper get polarized. Charge of comb or charged comb. A, B, C, and D.
It's because the atoms in paper gets polarized.
Yeah, is it option C?
Yeah, that's right. But here also they says comb possess magnetic property. Now, possess magnetic property?
So there is a formula, right? Q is equal to Q1 minus 1 by K to find induced charge.
But that here we don't need to.
No, like
We
I
will
wanted to do
just
questions on that one because I tried finding a few questions, but they were pretty difficult for me.
okay. Based on what?
Q dash is equal to minus Q into minus 1 by K.
Minus Q minus 1 by 1 by K.
Yeah, there's a
Okay.
formula, right?
Yeah. Okay, this for this also we will do question. Okay, yes, we'll do question on this. But this is my like next class timing actually. It's 7. Shall we do it in the next class?
Sure.
Okay.
Okay, sir.
Okay, dear.
Thank you, sir. Bye.
Bye bye everyone.